Alright, so this is 2.1 through 2.4 on speed, velocity, and acceleration. So first start, let's talk about motion as relative. So when we're talking about motion, it's always described by comparing it with respect to something else because we don't know if something is moving unless we are comparing our state of motion with something else, usually something stationary. Like right now, if I'm driving driving home and I'm looking at my speedometer and the speedometer reads 25 miles per hour. That's because that's my speed relative to the ground that I'm driving on. The Earth, from our perspective, is not moving, but from a perspective um, of other planets, it is moving. So here I have a photo of a series of school buses. Say, for example, you're on that one school bus right inside there. And let's just say that the school bus is driving at 55 miles per hour. How fast are you moving relative to the person that you're sitting next to? If your answer is 55 miles per hour, you are incorrect because just like how this Earth is moving like super, super fast, around 8 kilometers per second, you're looking at the person sitting next to you. Is that person really moving at 8 kilometers per second relative to you? Just like in the bus is driving 55 miles per hour. Is really that person you're sitting next to really you're really moving at 55 miles per hour compared to the person sitting next to you? Well, the correct answer is 0. You're not moving relative to the person next to you. However, if there's where this arrow is, if there's a person standing there and you're sitting on that school bus, which is driving at 55 miles per hour, how fast are you moving relative to the person standing right here on the side of the road? So if you said 55 miles per hour, you are now correct. So anytime you're moving, your motion is always compared to something else. All right? So let's just say you're deep, deep into space, no planets, no stars, no light anywhere around you. The only thing that you could see as far as your eyes could see is nothing. You have your thrusters on full, but you look out the window. Does it appear that you're moving? So motion is relative because it's relative to some other object. And if you don't have anything to compare it to, you really can't know whether you're moving or not. So when something is moving, we talk about how fast something is moving, or when something is moving, we talk about where it will end up. Now let's talk about speed first. Now speed is a measure of how fast something is moving, which is basically a rate. Now in the metric system, we are looking at meters per second as our units for speed. Meters is the distance, and seconds is the time. So since we're dealing with a rate, we're talking about something divided by time. Anytime there's a rate, it's some value divided by time. And what speed is, it's the distance traveled divided by the time. Now there are different kinds of speed. There's average speed, there's constant speed, there's instantaneous speed. Now with regards to instantaneous speed, it's the speed of an object at a given moment in time. So for example, I am running the distance of 3 blocks. The first block, I am basically running, as hard as I can. And let's just say I am able to run at 10 miles per hour. So I'm going pretty freaking fast the first block. But I'm pretty winded at the end of the first block, so I begin to walk the second block. And as I'm walking through the second block, I say, okay, I'm going to try running again the third block. But as soon as I cross the street to the third block, I started to pull my hamstring. So I'm hobbling, walking really slow, literally really slow compared to my fast-paced walk in the second block, which is, let's just say, 3 miles per hour. And then the last block, I'm basically hobbling, walking, stopping, cramping up at 1 miles per hour. So there we have instantaneous speed. So what is my instantaneous speed during my second block? Is it 10 miles per hour, 3 miles per hour, or 1 mile per hour? So instantaneous speed, to answer that question, is approximately 3 miles per hour. So it's the speed at that moment, at that instant in time, during the time that I was spent in the second block, as an example. Now, what average speed is, it's the total distance traveled for the trip as a whole divided by the total time it took. So if my total distance for that example was 3 blocks, and let's just say that I was able to run that first block in, say, 15 seconds. And the second block took me, say 60 seconds. And then the third block took me something like, oh, I don't know, I'm just making these numbers up. And let's just say it took me like, 120 seconds. So the total distance is 3 blocks divided by 120 seconds plus 60 seconds plus, say, 15 seconds. So that would be my average speed, which is the total distance, 3 blocks, divided by 195 seconds. That would be my average speed. The only thing about average speed is that it doesn't indicate any variations in speed during the entire trip. So it basically is pretty slow. Generally speaking, it's slower than the highest speed, but not as slow as the lowest speed. Now, the question is, I'm going to ask, is there any time in which an instantaneous speed and average speed would be the same? So think about that, write that question down, and then see if you're able to answer that question tomorrow. All right, so here's some conceptual questions. Now, the speedometer in every car also has an odometer that records the distance traveled. If the odometer reads 0 at the beginning of the trip and 35 kilometers half an hour later, what's the average speed? B, would it be possible to attain this average speed and never exceed a reading of 70 kilometers per hour on the speedometer? Number 2, if a cheetah can maintain a constant speed of 25 miles per second, or meters per second, it will cover 25 meters every second. At this rate, how far will it travel in 10 seconds? How about in 1 minute? So go ahead and pause and see if you're able to answer this question, or these questions. Hit pause now. So the answer for the conceptual questions for 1A and 1B is that the average speed is equal to the equation total distance divided by the time interval. So if you have 35 kilometers and you want to divide it by half an hour, so half an hour is 0.5 hour, that gives us 70 kilometers per hour. Now part B is asking if it be possible to attain this average speed and never exceed 70 kilometers per hour. Well, you got to remember, it's kind of like impossible because you start from rest. I mean, you start from 0. You're not instantaneously going to get to 70 kilometers per hour right away. So that means in order for a person to have an average speed of 70 kilometers per hour, that driver will have to exceed 70 kilometers per hour to kind of compensate for the, for the car to reach that average speed of 70 kilometers per hour. If you have any questions, ask tomorrow. So for number 2, with regards to the cheetah, and this is just a way to calculate, average speed is equal to, again, total distance divided by the time interval. And so the total distance is what we're asked to find for a cheetah running at 25 meters per second for 10 seconds. That's, just manipulate the equation by solving for d, by multiplying both sides with t, and you have total distance is equal to the velocity times the time, giving you 250 meters. And now if you look at the second equation, now basically asks you in 1 minute, but your velocity is given to you in meters per second, so you got to pay attention to the units and change the units to seconds before you can do the math. So it comes out to 1,500 meters. So some of you intuitively will be able to get that. Some of you maybe a little bit, shy on that. So just pay attention to the units. Now with regards to velocity, it's very similar to speed in that it includes the aspect of speed of how fast something moves in terms of distance divided by time, but it also includes a direction. So it's how fast and in what direction it is moving in. So a velocity is a vector quantity because it includes any sort of measurements and also uses direction. Now, a measurement that does not use direction is called a scalar quantity. So length, mass, volume, time, etc. So now here's a conceptual question. If we're looking at a speedometer of a car moving northward, which gives a direction, and it has the speedometer reading of 60 kilometers per hour. It passes another car that travels southward at 60 kilometers per hour. Both cars have the same speed? Answer yes or no. And then give me a why. B, do they have the same velocity? So if you need a few moments to think about this, hit pause before proceeding to the next, before hitting unpause to proceed to the next slide. So both cars will have the same speed because speed is speed. It's just how fast something is moving. And they will have different velocities because, well, they're moving in the opposite direction. The first car, A, is moving north. Car B is moving south. Different directions, different velocities. Now then there is also the concept of constant velocity, changing velocity, instantaneous velocity, the whole works. Not much has changed here, but I want to focus on constant velocity. Constant velocity is the velocity that doesn't change, which means same speed, same direction. Now when you have something that's a changing velocity, that means the speed and direction, or both, will change. So speed can change, direction can change. So you can have an object moving at a constant speed of, like, say, 10 miles per hour around a curve, changing velocity. Or if a person is hitting the brakes or accelerating forward, then that speed is changing even though the direction doesn't change. Then you have a changing velocity. So then that kind of goes into acceleration, because acceleration deals with how much an object can change its state of motion. So acceleration will change its speed, its direction, or both. So anytime there are changes in velocity, it's a change caused by an acceleration. So the focus on acceleration is the word change, a change in velocity. So the units for acceleration is meters per second because we're looking at the rate in which velocity changes. So therefore we take velocity divided by time. So velocity's unit is meters per second divided by time, so it's meters per second, which is essentially the units for acceleration. Now, in physics, we can say acceleration as an increase in speed or decrease in speed. In English, we say decelerate, but in physics, acceleration is just a change. By looking at the definition of change in velocity, a change could be a positive change, making it go faster, or negative change, making it go slower. So if you look at the arrow cursor here, I'm moving forward at constant velocity, but there's an acceleration from behind accelerating me forward. I can go faster. That's an acceleration. Another way is my cursor is moving upwards and then it's slowing down. That's an acceleration too. Okay. Another way accelerating is that if I'm accelerating this cursor from the left towards the right, and this object is moving forward at a constant velocity, and then it's accelerating towards the right, changing direction. That's also another form of acceleration. So, got a question? Ask, hit pause, write down the question, and ask tomorrow. Now, looking at this number 4, suppose that there's a car moving in a straight line, and it steadily increases its speed each second, first from 35 to 40, then 40 to 45 kilometers per hour, then 45 to 50 kilometers per hour. What is the car's acceleration? Hit pause, answer the question. Number 5. In 5 seconds, a car is moving in a straight line, increases its speed from 50 kilometers per hour to 65 miles per hour, or kilometers per hour, while a truck goes from rest to 15 kilometers per hour in a straight line. Which of the two vehicles undergo greater acceleration? Then tell me what the acceleration is for each vehicle. Go ahead and pause and answer the question before proceeding on. So now, with regards to number 4, the answer is the car will increase its speed by a rate of 5 kilometers per hour each second. So the acceleration will be 5 kilometers per hour per second. Again, pay attention to the units. See, hour per second, per kilometers per hour per second, or that's how you will write it. Now, both vehicles will have the same acceleration, even though they start off at different speeds. But the fact is, they will increase their speed by 15 kilometers per hour during that time interval, so their acceleration is the same. If you have a question, again, ask tomorrow, and see about getting your questions and concerns figured out tomorrow. All right, that's the end for this particular one. Have a good night.